A sender uses the stop-and-wait ARQ protocol for reliable transmission of frames. Frames are of size 1000 bytes and the transmission rate at the sender is 80 Kbps. 1 Kbps equal to 1000 bits per second. Size of an acknowledgement is 100 bytes and the transmission rate at the receiver is 8 Kbps. The one-way propagation delay is 100 milliseconds. Assuming no frame is lost, the sender throughput is dash bytes per second. So this is a question regarding stop and wait protocol from computer networks. Here we just need to find out what the throughput would be at the sender side. So in the question they have given that the sender bandwidth and the receiver bandwidth are different. Sender has a higher bandwidth of 80 Kbps, receiver has a lower bandwidth of 8 Kbps. The propagation delay is also given. So this is how stop and wait protocol looks. If this is a sender and this is a receiver, for sending one packet, it will be sending one packet first and then wait for its acknowledgement and then repeat the same thing again. It will be waiting for acknowledgement for each and every packet. So for the first packet, it will have a transmission delay at the sender for sending the packet, and then it will have a propagation delay. That's the time taken for the packet to reach from the sender to the receiver. After that, the receiver will process it. There is nothing given in the question about processing delays or anything, so we will assume it is 0. After that, the receiver will transmit the acknowledgement back. So it will have another transmission delay for the acknowledgement, and then it will be, the acknowledgement also needs to propagate back to the sender. So that will also add a propagation delay. So the total delays would be T transmission at the sender plus T propagation plus T transmission of acknowledgement plus T propagation for the acknowledgement. And the efficiency will be only this part out of the total. This is the total time taken and this is the time taken doing useful work, that is sending the packet. So efficiency would be T transmission at the sender divided by T transmission plus T propagation plus T transmission of acknowledgement plus T propagation. Now let us calculate all of these values. In the question it is given that T propagation is 0.1 seconds. It's given here propagation delay is 100 milliseconds, that is 0.1 seconds. So this and this is the same only, that is 0.1 second each. Now T transmission at the sender is equal to L by B, where L is the packet size and B is the bandwidth. Then the packet size is, it's given that frames are of size 1000 bytes, that is 1000 into 8 bits divided by the bandwidth is 80 Kbps, that is 80 into 10 raised to 3 bits per second. It's given in the question only. That will be equal to 0.1 second. So T transmission at the sender will be 0.1 second. Now we'll find out the T transmission for the acknowledgement, that is again L by B, where the packet size of the acknowledgement is only 100 bytes now, that is 100 into 8 bits divided by, at the sender, at the receiver the transmission rate is a lower one, that is 8 Kbps. So the receiver can only transmit at this rate. That will mean L by B would be 100 into 8 bits divided by 8 into 10 raised to 3 bits per second, since receiver had a lower transmission rate. That will be again 0.1 seconds. So all of these delays are 0.1 seconds. Now we can calculate the efficiency, that's equal to T transmission divided by TT plus TP plus T transmission of acknowledgement plus TP, that is 0.1 divided by 0.1 plus 0.1 plus 0.1 plus 0.1, that is 0.1 divided by 0.4 or 25%. Now we will find out the throughput. Sender throughput will be same as, here we have found out that the efficiency is 25% only. So sender throughput would be 25% of the sender's bandwidth. That is 1 by 4 into the sender's bandwidth was 80 kilobits per second or 10 kilobytes per second. That is 10 into 10 raised to 3 bytes per second. That is 2500 bytes per second. In the question they were asking for bytes per second. So the answer is 2500.